Hey everyone, welcome back to BrainyLab, your home for fun and easy science tutorials. In today's video, we're diving deep into one of the most fascinating topics in chemistry, shells, subshells, and orbitals. We are going to divide this topic into two parts. This video covers the first, subtitled Bohr's Atomic Model. By the end of this video, you'll understand how electrons are arranged around an atom and why this arrangement determines an element's properties. So, grab your periodic table and let's get started. An atom is the smallest unit of an element. It consists of a central, positively charged nucleus containing protons and neutrons surrounded by a cloud of negatively charged electrons. The nucleus holds nearly all of an atom's mass, while the electrons occupy a much larger volume of mostly empty space. The clip-on display illustrates the atomic structure. The protons and neutrons in the nucleus are represented in black and white, respectively, while the electrons are represented in red, orbiting the nucleus in orbital shells. Let's begin with electron shells, also called energy levels. Think of shells as the layers or floors surrounding an atom's nucleus. Each shell represents a specific energy level where electrons are likely to be found. The shells are labeled as K, L, M, N, O, P, and Q, starting from the one closest to the nucleus. The following formula gives the number of electrons that each shell can hold, where N is the shell number. So, for example, the first shell, N equals 1, can hold 2 electrons. The second shell, N equals 2, can hold 8 electrons. The third shell, N equals 3, can hold 18 electrons, and so on. This way of illustrating an atom is called Bohr's atomic model, named after Niels Bohr, who developed it. Now let's look at Bohr's atomic model for 3 examples of elements on the periodic table. Example 1, sodium. In the periodic table, we find that sodium has a proton number of 11. Remember that in an uncharged atom, the number of protons is always equal to the number of electrons. Therefore, we have to illustrate Bohr's atomic model with 11 electrons in the shells. Remember, the first shell can hold 2 electrons, so we put 2 electrons in the first shell, also known as the K shell. This leaves us with 9 electrons. Using the formula we mentioned earlier, we know that the second shell, L shell, can hold 8 electrons, so we put 8 electrons in it. This leaves us with 1 electron left for the third shell, also known as the M shell. This means that sodium has 1 electron in its outer shell, as shown in the diagram. Let's move on to the following example. Example 2, aluminium. In the periodic table, we find that aluminium has a proton number of 13. Now, to draw aluminium's Bohr model, we start by putting 2 electrons in the K shell, since it can hold 2, leaving us with 11 electrons. Next, we place 8 electrons in the L shell, since it can hold 8, leaving us with 3 electrons in the M shell. This means aluminium has 3 electrons in the outer shell. For our last example, we will look at argon. In the periodic table, we find that argon has a proton number of 18, therefore it has 18 electrons. To draw the argon Bohr model, we first assign 2 electrons to the K shell, since it can only hold 2 electrons. This leaves us with 16 electrons. Next, we assign 8 electrons to the L shell, since it can have only 8. Last but not least, we assign the remaining 8 electrons to the M shell. The M shell holds 18 electrons. If you take a look, you notice that the group number directly corresponds to the number of outer shell. Valence electrons. For example, sodium, in group 1 on the periodic table, has a valence of 1 electron in the outer shell. Aluminium is in group 3, and as we saw in example 2, it has a valence of 3. Argon is in group 8, also known as group 0, and has a valence of 8. Now for practice, try to draw Bohr's atomic diagrams for silicon and chlorine. The answers will be at the end of their video. This concludes the first part of the Shells, Subshells, and Orbitals series. Stay tuned for the second part, which will cover off-bow diagrams. Please like, share, and hit the subscribe button if you found this helpful. See you in our next video on BrainyLab.